Huh?
I was thinking, does there have to be an extra temperature from a radiation oncologist?
No.
It's more easy to get in if you are, but no, you don't have to be. Okay, so that's the Röntgen. Okay, now the unit that's competing with and taking over the Röntgen is the rad. Okay, and you also need to know that the SI unit is the gray. Okay, 100 rads equals 1 gray. Okay, so in the traditional sense of the term here, okay, the definition of a rad is 100 ergs per gram. Now this means for any type of radiation and any type of material. Okay? So we're no longer just dealing with electromagnetic, we're dealing with alpha particles, beta particles, positrons, everything. Okay, so all types of radiation, all types of material, and 100 ergs of energy absorbed per gram. Okay? And I told you that an erg is the CGS unit. Basically, if I take 1 gram and I accelerate it 1 centimeter per second, that's called a dyne. Okay? If I continue that acceleration, then, so what I have, a dyne is 1 gram accelerated 1 centimeter. Okay? And if I multiply that times the duration of the force being applied, then I have an erg. Okay? It's kind of a weird concept, but okay. But anyway, ergs. So, like in this case over here. So, if I applied a force for 5 seconds, so 1 gram accelerated 1 centimeter per second, and then I multiply that times 5 seconds, then I would have ergs. I would convert a dyne to an erg. Okay. The gray, on the other hand. Notice that you can say that it's 100 rads or 1 joule per kilogram. Remember, joule is the unit of energy that we talked about before? You can also convert that into heat if you want. I put it down here. Because one of the things that radiation does is it passes through material as it generates heat, as well as ionizing stuff. Okay, so that's the rad. Yes, sir.
You have to know all of the conversion factors.
Yeah, actually you do. On the board, I mean, this really isn't this bad though. You know, with the Röntgen, just remember it's the unit of exposure, it's a volume of air, or it's a number of...
That's the intensity of the air, but you want us to know equals the coulombs, kilograms, all that.
Right? Now, on this thing down here, and this should be 10 to the 7th ergs up here. 10 to the 7th ergs per kilogram. What I'm mainly concerned of is that you understand that an erg, the best way to think of this is, you know, I told you putting your hand on a frying pan. Okay, you put your hand on a frying pan, and then the longer you leave it there, and the more energy it absorbs, the more damage it's going to create. Okay? And that's where these things are used here. This is telling you how much energy is being deposited. Okay? And on your board exams, one of the things in your math book you might want to take a look at, it's on page, it goes from pages, well, 32 to 39. There's a bunch of conversions in the book. 32, it shows you how to do Becquerel, which we've already done. But starting on page page 35, okay, converting between rad and gray. Okay, and as I said, the SI units haven't taken off yet, so I don't know on your board exam you can expect to have one or the other, or both. I know that when the last time I looked at the tests for the Nmtt4of2, they had both on there. Okay? But remember that 1 rad is equal to 1 centigrade. You might want to put that down there, that a centigrade equals 1 rad, because that's 1/100th of a gray. Yeah, a centigrade or 1/100th of a gray equals 1 rad. Okay? And then if you're going in the opposite direction, you're just going to multiply it by 100 to change it. Okay. So on page 35, there's a bunch of questions. And as I said, I know you guys have all this spare time, right? So after you've done your 36 hours or 32 hours of clinical, and after you've driven 4 hours back and forth to your clinical assignments, then you can rush right home and start doing these exercises. But I really strongly, one of the reasons why I wanted you to have these books, not only because the society was going to give them to us, but the thing is, this is a real handy thing. My daughter uses these all the time at her work assignment. Now, you guys may be on your own, and if you have these resources here, here's the other thing here. Now, the REM and the sievert are what we use to explain the biological damage to you and your patient. And in this thing here, if you look at my little handout, we multiply the absorbed dose that you've been exposed to times either a quality factor or times what we call relative biological effectiveness based on the type of radiation you've been exposed to. Okay? And that's what they're saying here. So let's take a look at that for a second. And basically we have that same proportion. So 100 REM is equal to 1 sievert. Okay? We call that the dose equivalent. One of the fun things I like to do is, let's say that Mr. Radke took you on a nice trip to the San Onofre nuclear reactor. Okay. Well, first of all, let's go down here and take a look at this. We're going to talk about relative biological effectiveness. One of the fun things that I got to do as a student here was see how much radiation it takes to kill bacteria. Because my project here was comparing which types of bacteria are more resistant to radiation. Okay, so I had Staph aureus, E. coli, Bacillus cereus, and I was exposing all 3 of those. Now, I was hoping that they would die off within a few hundred rads. Because does anybody know how much radiation it takes to kill a human?
500 rads? 300 to 500 rads?
Yeah, about 300 to 500 rads. Okay, and so you're going to die in about a month from blood problems. You're not going to have any platelets. You're not going to have any. But how much radiation do you think it takes to kill bacteria?
200.
Okay, actually, it was over 1 million. Yeah, the Staph aureus, the last colony of bacteria that I was able to grow, the Staph aureus, was after 850,000 rads. The E. coli, which is a spore-forming bacteria, or was it? Yeah. It took over 1 million. I still had 1 colony of bacteria. I wound up spending my whole Christmas vacation running back and forth between here and the radiation therapy department collecting samples and culturing them. And of course they were growing in the back of my trunk. About that time that movie, The Andromeda Strain, came out. So I had visions of me getting into an accident and my radiation mutated bacteria taking over the world. Of course, they would elect me their president because I created them. But. Okay, but let's talk about quality factor. Do you guys need a break for about 10 minutes?
Yeah.
So that was 300 and 500?
Yeah, 305. We're going to go into that because if we don't cover radiation biology now, we'll cover it before you guys take your boards. Okay.